All right, here we are. Lecture 2, round 2. Let's do it. We're going to be talking about like the basics of life slash human biology right now. And like these are how I'm going to do most of the lectures, is with this little whiteboard. So this is kind of the topic for the lecture, and we're just going to go through this. So like, life is a kind of crazy thing. What is it? And we'll talk more about this, but like at the base of all life, like you have no life without water. None. Doesn't exist, at least on planet Earth. Gotta have this guy. This is utmost supreme. This is supposed to be a star. What did I just do? Gotta go back to kindergarten. All right, water. Boom. Gotta have it. And there are all kinds of different definitions of why we need life. But we're going to make that into a discussion post. And you guys we're going to define together what life is this week in our discussion post. We're not going to look it up. We're going to define it together. And we can refine that throughout the semester and see how that definition grows or changes. Pretty cool. Okay, but we know we definitely need water. And there's a kind of crazy, fascinating thing about life. It's that life is made out of the same stuff as non-life. And we're going to be talking about chemistry and stuff next week. But the same stuff that you find out in rocks in the universe is also what life is made out of. So we got some basic elements that life is made out of. One of them is hydrogen. Actually, we'll start with nitrogen, even though it's not very prevalent. It's kind of the least of the main four. Nitrogen, oxygen, carbon, hydrogen, phosphorus, and last but not least, sulfur. These are main things that life are made out of. And why did I write them in this way? NOCHPS. Let's just write that out. NOCHPS. Oh, it looks like no chips. That's how you can remember it. No chips. Nitrogen, oxygen, carbon, hydrogen, phosphorus, sulfur. This guy, if you actually like take the percentage, or like the count the number of atoms, this one makes up the most. This would be 62%. It's different for weight. This would make up 62% of the atoms in a human body. This is the next. This is like 24. Carbon is next. It's like around 12. And then we get into nitrogen, which is like 1 or 2%. And then phosphorus and sulfur, not even a single percent. These are less than a percent. And then there's other things in there too also that are in this less than a percent category. Things like sodium, chlorine, potassium, magnesium, so on and so forth. These are all also less than a percent. That's it. That's what human beings are made out of. Oh, we should probably also throw this one in there. Calcium, right? That's what our bones is made out of mostly. Calcium and phosphate. That's crazy. Like that's, just atoms, you can find on the periodic table. This is what stars are made out of, hydrogen. This is what your pencil lead is made out of, carbon. The atmosphere is made out of oxygen and nitrogen and carbon. Phosphorus is, found in fertilizer, which is part of life. That makes sense. Sodium is salt, just a natural element out in the universe. And that's what we're built out of. Pretty weird. I don't know, maybe this is an omen or a sign. Don't eat chips, but chips are so delicious. But these are the elements that make up the main components of life. Pretty cool, pretty crazy. All right, so let's talk like a little bit about how this course is going to be organized, and how life is organized into these interesting layers. These stratified, which means just layers upon layers. And I guess we'll start at the bottom, which is not even really the bottom, but it'll be our bottom, which is just atoms. And we'll start with carbon atom. And atoms look something like this. And this, we'll talk about how I'm drawing these atoms specifically here in the next couple lectures, but we've got kind of these things called orbitals that go around like so. And they've got things called electrons that kind of circle them. And carbon has a total of 6 electrons. So that means it's going to have 4 out here, like so. So this would be our like we're going to be talking about this semester. These are atoms. These are the smallest unit of an element. Smallest unit of an element. These things are pretty cool. If you're going to take chemistry, you're going to love it. It's fascinating. We get to touch a little bit on it. And these things are made out of protons, which are in the nucleus. They'd be in here. Neutrons and electrons. And we'll talk about those in more detail in the next couple of lectures next week. But those things are all then smashable, and you can go even further down here. We can get smaller, but we're just not going to talk about that in this class. But science goes smaller than this. We know about quarks and bosons and wave quanta, all kinds of cool business. My favorite quark is a charm quark. All right, well, then we go up from here, and what do we get? We got a molecule. So we take a couple atoms and smush them together, and we'll make, well, let's make water. We were talking about water. Let's go ahead and just make that one. So water will look something like this. We got 2 hydrogens and an oxygen. So let me go to my letters. So we got oxygen. We'll make oxygen blue. We'll make it red. We'll make oxygen red. So we got our O, and then we'll make our rings around that. So oxygen's got that one inner ring, and then it's got its outer ring like so. And then we're going to have 2 hydrogens. You guys are getting a little sneak peek in what we're going to be doing over the next week here or whatever. So we got our oxygen electrons there, 2 in there, and then it's going to have 6 actually. 1, 2, 3, 4, 5, 6. Then we're going to do our hydrogens. And hydrogen is our first element. It's only got 1 valence shell. Ooh, don't want that so thick. I'm going to move that guy around a little bit. And they're going to be sharing 1 electron. The cool thing about water is when you build it like this little thing that I'm making, it's called a Bohr model. It looks like a little Mickey Mouse. Oh, I actually hate Disney with a passion. I think it's trash. Everything about it is trash. It's garbage. Quit giving them your money. But the fact that it looks like Mickey Mouse is pretty dope. So this is a molecule. Molecules are combinations of various elements bounded together. Molecule. It's the molecule. So we got the atomic level, the molecular level. Get rid of that. Put it right there. We got atoms. We got the molecule. So this is yeah, 2 or more atoms bound together. And they're bound together by sharing electrons in this case. And we'll talk about all that in the future. All right. This is also irritating me that that's too thick. I don't want that too thick. So we can get smaller in that direction. Okay. So what comes after molecule? Well, then we get into, in the biological context, we get into something called cells. So cells are really what we consider the basic unit of all life. All living things are made out of cells. So if we go like this, we can draw a couple different kinds of cells. We'll draw like a little neuron. That's kind of trashy. Let me redo this. I gotta do this right. There we go. Now we're talking. Yeah, that's much better. I've gotten pretty good drawing with a mouse. Okay, I spoke too soon. So we got ourselves a little neuron. They look something like this. They got like little protrusions coming off of them. And this is how they talk to each other. They kind of touch each other with these little things. It's pretty nifty. Okay, so we got cell. We got a nerve cell there. Let me label that as such. Got ourselves a little nerve cell. That's a nerve cell. So we got the cellular level. We're going to be spending a decent amount of time here after we go through chemistry. We're going to be talking about the cellular level. So cells are basic unit of life. So a single cell is alive, and we are made out of 37 trillion human cells. Pretty crazy. Pretty crazy. There's 400 billion stars in the night sky. We decimate that number with the number of cells in our body. Okay. Then you go from cells. We're going to be spending a lot of time here at atoms, the molecule, and the cellular level. Then we're going to increase from there. Get a bunch of these cells together, and you guys should be taking notes on this. So we got a bunch of these cells together now. Like, you should be drawing all of this out. I want to make sure that's clear. Because you are going to be graded on this. You are going to be getting points from this. So then we have the layer of tissue. And you can feel free to do this quickly. I know I just copied those and it might feel like cheating. But you can, it doesn't have to be perfect. You can draw it quickly. Tissue is multiple types of cells coming together to perform, there's the word, a specific function. So we're drawing nerve cells, so now we have some nerve tissue, and we might even draw in a second type of nerve cell found in nervous tissue. So maybe we've got something like this guy, let's say. Maybe he's coming in and he's got his little foot, and his little foot wraps around here. Let's just say it looks like that. I drew that real simple, but you get the idea. And these would, of course, be found on all of these. So now we got these multiple cell types coming together to perform this function. So that's a tissue. From there, we get into an organ. So nervous tissue, the organ that would make up. Obviously, you guys probably know what it is. That would be our brain. Our brain looks something like this, kind of a lumpy boy. It's got this stuff in the back here. And then it's got a little brain stem. So this would be a brain. This level would be the organ level. So organ is composed of multiple tissues coming together to perform a specific task or a specific function. So you got all different parts of your brain, different things that they provide barriers or nourishment or protection. All different kinds of tissues come together to form the brain. They all perform their own little set specific function. Then after the organ level, we have, maybe not too crazy to think about, but it would be the organ system. Organ system. So this would be like your nervous system. So now if we look at the brain kind of head on, like a front view, we would look something like this. This would be the brain up here. And then we would have our spinal column, or our spinal cord, sorry. And then off of this, we would have all these peripheral nerves coming off like this. This would be our organ system. This would be our nervous system. So for example, we have our peripheral nervous system and our central nervous system coming together to make our nervous system. So these are multiple different organs working together. So an organ system is pretty basic and straightforward. Multiple organs working together to perform a specific function. Pretty nifty. Pretty nifty indeed. All right, that's fantastic. All right, that's our organ system. And then from there we have an organism. This is pretty crazy how this nomenclature, this naming system works. So from here we have an organism, which obviously would be a human being. And let's see how trash of a human I can draw, because I'm actually not that great at drawing. All right. It's not terrible so far. Yeah, it's a little alien-like. I like it. Uh-huh. Yep, that's where it all fell apart. It's okay, we're just going to go with it. Okay. All right. Now he's a crab person. Oh. Yep. Okay, yep. That's a Slender Man. Yeah, it's me. Oh boy, what did I do? Schmerg. Great. Got to give him the hair. Perfect. That is a perfect rendition of me. We've got ourselves an organism. Pretty cool. And really, we're going to be spending most of our time, this is multiple organ systems coming together to make an organism. Pretty crazy when you think about yourself that way. You're just a bunch of organ systems coming together to make an organism. Pretty weird. I'm an organism. Yeah, we consider this a biological individual. Individual. So it doesn't actually have to be like you can have a bacteria, that's an organism, but it doesn't have organ systems. So it's also a biological individual, if that makes sense. Because some organisms are single cellular. All right, we got all that. And we're still not done. I'm not going to draw out the rest of them because we're not actually going to spend too much time on these. But I just want to make it clear that this continues on. So then we have a population, which is, I mean, I can just copy and paste this one out. It's multiple types of the same organism interacting together. Multiple organisms of the same type interacting with each other, like in the same area. That's a population. Then from here we go into a community, which is probably, you could probably guess what that is. A community multiple different types of organisms interacting with each other. I am, for the record, a terrible speller, and you will get used to that. So feel free to make fun of me about that. Then we go on to an ecosystem. Ecosystem. It's pretty cool. Ecosystem, which is multiple, which is a community interacting with their environment. It's a community plus the environment. So it's the organisms plus the environment. So it's like the humans, the grass, the cows, the wheat, the bugs, and the rocks, and the water. That's an ecosystem. And then finally, we've got the biosphere. And we'll touch on all of these a little bit throughout the semester, but we're not going to be spending most of our time here in the biosphere. It's obviously, you know, the whole shebangy, the whole Earth. You know, I'll do my best to draw a little North and South America here. Got to get Florida on there. There you go. Terrible. But that, you know, it's the whole frickin' Earth, the biosphere. The whole dang Earth. That's where everything happens that we know about as far as life goes. Someday we'll know more, I hope. Because there's most certainly life on other planets. We just have to get out there and find it. But there's no biological reason that it can't exist, and it might be really, really interesting. Okay, so let's just do a little quick review on that. So we are going to be covering in this course, this is where we're going to start. Next week is in atoms. We're then going to get into molecules and basic chemistry, spend some time on cells, which is my favorite topic. I'm a cell biologist. So we're going to be spending quite a bit of time there. And then we'll be also spending a lot of time in tissues. We have a whole week kind of dedicated to that. And then we will spend, you know, a lot of time in the organ level, but then kind of once we get out of cells, we're going to be going through different organ systems of the human body, of the human organism. And we're going to spend a good chunk of the semester going through like the nervous system, the digestive system, the cardiovascular system, skeletal, muscular, so on and so forth. And then we'll get into some more cellular topics, things like cancer and aging, that are things that are happening at the cellular and tissue level, but they're affecting the organism, the individual. So yeah, I hope you learned a little something there. That's where we're gonna go from. And it's kind of crazy because all of this biosphere, all of this, all of it, atoms. It's built out of atoms, and the life part of all of it is built out of nitrogen, oxygen, carbon, hydrogen, phosphorus, and sulfur mostly. There's over 100 elements, and its life is built out of that six mostly, and really it's mostly these three: nitrogen, oxygen, carbon, and hydrogen. It's pretty nifty. Okay, I'll see you guys in the next lecture.